Well, thank you so much for joining this lesson. We're going to discuss mathematics paper 1. This will be a continuation of the color joint examination. And as we start, the first thing that we're going to do is to look at a book here, a Kiswahili book authored by Nixon Amisi, assisted by Ann Amos. Ann Amos is a teacher at Machako School, Antling Kiswahili. And when you purchase this copy, Kichala cha Ushairi, you're really going to benefit. So make sure you get your copy through Madam Amos. Our number is 0724 105 709. Please master that number. I want to repeat it again. 0724 105 709. Through that number, you're going to get a copy of yourself. The delivery is done countrywide. So wherever you are, feel free to inquire through Madam Amos and you're going to benefit in your Kiswahili. Allow me now focus on today's lesson, whereby we're going to continue with this paper. We have already started. We did all the way from number 1 to number 6. And during this lesson, we will be focusing with number 7 onwards. Number 7 onwards. Yeah, remember to comment, remember to subscribe, remember to share, invite a friend to today's broadcast. Number 7, let me begin. A train moving at 95 kilometers per hour on parallel track to a road is 18 meters behind a bus. Then the bus is 12 meters long, moving in the same direction at 80 kilometers per hour. If the train takes 43.2 seconds to completely overtake the bus, determine the length of the train in meters. When you look at this question, there is a speed in kilometers per hour, but when we get to the distances of the train, the distance how the train is behind the bus, they are in meters. The time taken is in seconds, and that means there is a great need to convert our speed from kilometers per hour to meters per second. Before that conversion, allow me sketch this information diagrammatically. And as we continue, obviously, our number remains 0704 15 33 66. Please reach out through this number and we're going to grow together. When I talk about a train, a train which is having a known length, that length can be let to be x meters long. So this is a train which is x meters long, x meters. This train, let me call it train at this point. This train is 18 meters behind a bus. So 18 meters behind a bus means there are 18 meters at this point. Then now a bus is here. We got a bus now. The bus is 12 meters long. Then we are told that the train takes 43.2 seconds to completely overtake the bus. That means for it to overtake the bus, it has to cover all this distance. The train has to move all this distance. From this point to this point, the total distance is going to be x plus 18 plus 12. So the total distance which is going to be moved by the train for it to completely overtake the bus is going to be x plus 18 plus 20, which is 30 plus x. 30 plus x meters. Then we are now given the time taken to cover this distance. And remember, with the two vehicles moving in the same direction, there is what we call overtaking speed. In this question, there is an overtaking speed of 95 minus 80. 95 minus 80, because they are moving in the same direction, 15 kilometers per hour. This is the overtaking speed. Now, we are supposed to understand that with the overtaking speed, we have to change it to meters per second. 15 kilometers out of 1 hour means for the kilometers, we multiply them by 1,000 to make them meters. And for the hour, we multiply it by 3600 to make it seconds. And so we shall have 15,000 being divided by 3600 to be 4 and a sixth. Now, 4 and a sixth is our speed now in meters per second. With speed in meters per second, we can now, it's now relative speed and we have relative distance. We should say that distance is usually given by speed times time. So the distance of 30 plus x is given by a speed of 4 and a sixth multiplied by 43.2 seconds. So 30 plus x is equivalent to, we multiply this by 43.2. This gives us exactly 180. So as to remain with x, we subtract 30 where there is 180. This gives us exactly 150 meters. So the length of the train is 150 meters. 150 meters. We continue. There is a number 8 here. A very good question from Form 1, the regular polygons. In the figure below, ABCDE is a regular pentagon and PCD is an equilateral triangle. PCD is an equilateral triangle, this one. Yeah. The other one is a regular pentagon, meaning that all the interior angles are equal in such a figure. Find the size of PDA angle, another angle DAP, another angle BCP. Those are the angles that we're going to calculate. Something you're supposed to know, in an equilateral triangle, all the angles are equal. For instance, this is 60, this is 60, this is 60. And something else you're supposed to know, in a regular pentagon, all the interior angles are also equal. So let's get the length of the interior angles. Length of interior angles. We should know that the sum of all the interior angles in a pentagon, it's usually given by 180 multiplied by n minus 2. This being pentagon means 180 into 5 minus 2, which means 180 by 3, and this is 540. Now, with 540 as the sum of interior, we can get then now the size of each angle. 540 divided by, there are 5 of them. So each is going to be, when we divide by 5, we get 108. So each interior angle is 108. So all these angles you see are each 108. Even the big angle at this point is 108, 108, all of them. And now the angle, remember we are supposed to first of all get PDA. PDA, the angle at this point, PDA. So let's continue working out now the several angles. You should know that with exactly 60 at the center, then we are having a line PA. The line PA is going to divide the angle at A into 2, and it's already 108. So the angle will be 54. So we shall have a 54 at this point and a bigger 54 on the other side. A bigger 54, because there are two angles there. Again, there is something that we should understand. Remember, this is regular, so these sides are still equal. So with 108, we can get the base angles taking isosceles triangle DEA. DEA. So with DEA, we need 180 minus 108 to give us 72 over 2, giving us 36. So the angle at this point is 36. And also, the angle at the other point is also 36, which means if this is also 36, then the remaining small angles here now can be obtained. The remaining angles there can be obtained. And PDA is going to be the whole angle of 108. Then we subtract. The whole angle of 108, we subtract 60 and 36. And the angle becomes exactly 12. So PDA is 12 degrees. There is another angle, DAP. Angle DAP is going to be determined also. DAP, the angle on the other side. For us to get DAP, now we are supposed to work with 54 and 36. So we'll need the bigger angle of 108 minus 54, 36. This is going to give us 108 minus 54 and 36. This gives us exactly 18. So this is going to be 18 degrees. We proceed to triangle BCP. BCP. When we talk of BCP, we mean this angle. Remember, the bigger angle is 108. So there is a smaller angle of 60, which means the remaining angle will be 108 minus 60, giving us exactly 48. So the value of this angle is 48. That is how simple it was to maneuver through these angles in the regular pentagon, which was provided in number 8. We proceed to number 9. 4 years ago, a father was 3 times the age of the son. A father was 3 times the age of the son. In 10 years' time, the sum of their ages will be 88. Find the age of the father when the son was 5 years old. So we're going to play around with these word problems until we get to know the age of the father when the son was 5 years old. So 4 years ago, a father was 3 times the age of the son. 3 times the age of the son. So we will talk of a father. Then we will also talk of the son. Let me summarize this in a table. In a table, father and son. Father and son. Then we can start now with 4 years ago. 4 years ago. If we are talking about ago, then the son being X, or letting the son to be X, then the father would have been 3 times the age of the son. 3 times the age of the son. That is 4 years ago. What about present? What about present? Their present ages means if this was 4 years ago, then it means present age, each person has added 4. And also the son will have also added 4. In 10 years' time, how are they going to be? 10 years' time. 10 years' time, now we shall talk of, let me write it well, 10 years' time. 10 years' time, the father will add 10, so you'll be 3x plus 14. The son will also have added 10, it will be x plus 14. Now we are given a condition at this point that 10 years' time, in 10 years' time, the sum of the ages will be 88. So when we take 3x plus 14, then we add x plus 14, we shall get 88 years. Sorry, write it well. We shall get 88 years. So 4x is equivalent to, we have to take 88, then we subtract 14 and 14, which is 28. This is going to be 60. And this is to mean that the value of x is going to be exactly 15. If the value of x is 15 years, if the value of x is 15 years, then it means for the sun, or their percentages now, can now compute percentages and say that presently the sun is equivalent to, when we take x 15 plus 4, the sun is now 19, and the father is now 15 by 3. This is going to give us a 45. Then we add 4. This is going to be 49. This is going to be 49. So presently, the father is 49, the son is 19. Then we are finding the age of the father when the son was 5 years old. So when the son was 5 years old, it means from 19, how many years ago? From 19. For him to be 5 years, it means 14 years ago. So 14 years ago, in other words, 14 years ago, this is when the son was 5 years, then the dad was at a certain age, and that will be 49 minus 14. So that means the father was 35 years. The father was 35 years of age. So that is how we get the age of the father when the son was 5 years of age. Let's proceed. Remember to subscribe. Remember to invite friends to our broadcasts. Comment. Let's know where you are watching us from. Somebody saying really waiting. From Garissa County. Thank you so much. Ikalas High School, St. Martin Kitale. My name is Ewoy. Thank you so much. Molu Joseph Katoloni Secondary. Thank you so much, Katoloni Secondary. Mukabo is well represented. Thank you so much, Mukaboys. I request you guys to invite your friends, invite your schoolmates. Yeah, across all the forms. There is a lot to learn from everybody. Elizabeth Muse from Nairobi County. Thank you so much. Remember the Ushairi book from Madam Amos 07 24 105 709. That number is going to really help you access a lot of materials in Kiswahili, and you are going to generally improve in the language. All right, by shading the unwanted region, determine and label the region R that satisfies the three inequalities: 2y less than or equal to 3, y plus 2x greater than 0, then 5x minus 6y less than or equal to 30. Remember, at this point, we're going to have a complete line because there is or equal to. At this point, the line is going to be incomplete, or simply it's going to be dotted. At this point, we shall have a complete line. So when there is less than or equal to, or greater than or equal to, then we usually have complete lines. But for strictly greater than, the line is supposed to be dotted. Okay, for us to get these lines, we get borderlines from inequalities. Let me use the right language now. We get borderlines from inequalities. And now that we have the inequalities, then we assume the borderlines now. 2y equals to 3 will be the first borderline to represent the first inequality. Then the second borderline will be y plus 2x equals to 0. And the last borderline shall be 5x minus 6y equals to 30. So these are the three boundaries or borderlines that we are going to trade with. Let's start with a table of values for the first borderline. So for the first borderline, we shall talk of values of x and values of y, though the values of y are not related to values of x. We can say y is equivalent to 3 over 2, which is 1.5. So line y equals to 1.5, y equals to 1.5. 1.5. The line is automatically going to be at this point. Y equals to 1.5, exactly between 2 and 1. That is the line. Remember, we said the line is supposed to be complete. Y equals to 1.5. The next borderline, now we come up with the what we call tables of values, x and y. We can start when x is 0. The value of y is also going to be 0. You just substitute 0 and 0. So whether is x, you put 0, the value of y automatically becomes 0. If the value of y, if the value of x, we take it to 1, for example, the value of y is going to be negative 2. If we take the value of y, if we take the value of x to be something like 2, then we can substitute again and get the value of y as negative 4. So we start with 0, 0, 1, negative 2. This is the coordinate 0, 0, 1, negative 2, then 2, negative 4. Yeah, those are two coordinates. Let me first of all prolong the first borderline. Let me prolong that borderline. Then now we are talking of another borderline passing through the origin and those plotted coordinates. Yeah, that is now the next borderline. And finally, we will have a borderline which we are calling 5x minus y. 5x minus 6y equals to 30. So we can talk of a table of values now, x and y. Then we begin with x being 0. When x is 0, we just substitute 0 where there is x, and it will be 30 over negative 6, giving us negative 5. Then we can also have at the point when y is going to be 0, what will be the value of x? So when y is 0, the value of x will be positive 6. The value of x is going to be positive 6. And now that positive 6, yeah, we have positive 6, we have a negative 5, all those values are there. We can get other values like, let's check whether at 2, we shall have a rational number. At x equals to 2, it will be 30 minus 5 into 2. Then we divide by 6. You see now the number will be 3.33. So that will be 3.33. We can check at 1 and see how it will be. So negative 6 will be equal to 30 minus 5 into 1. So it's going to be, when we divide by 6, it will be 4.2. 4.2. So let's look at such coordinates. 0, negative 5. 0, negative 5. That is the y-intercept. Then 0 or 60. 60 is going to be here. So that is what we're going to connect. That's exactly what we're going to connect. for us to get the borderline. So let me plot this borderline now. Remember, the other coordinates are just estimates because of the decimal points. So allow me use these exact coordinates for now. The exact coordinates. You can even get other coordinates and use a straight ruler to join them. These are now the three borderlines. These are the three borderlines. The three borderlines, and we can see that the region which has been bordered by the three is just a very small region, because we're going to shade these parts. Then we are also shading this part, and we shade this part. Therefore, the region which has been surrounded or bordered by the three is going to be labeled region R. Let me label it. This is the region R now, which has been surrounded. The region R has been identified using that yellow arrow. That is the region bounded by the three inequalities. So thank you so much. Yeah, thank you so much for those who are contributing. Let's continue. Well, we are now at number 11. Yeah, it's number 11. Paul's triangular plot is represented by 7,000 or 700 square centimeters on a map R and 252 square centimeters on map T. If the scale of map T is 1:50,000, find the scale of map R. So what we shall tell ourselves is that this one now, on the map, we usually have the linear scale. So this is the linear scale, which means that the area scale for map T, is specified. Area scale for map T is going to be, we take 1:50,000 and we square. This is going to give us this is going to be 25. Then the number of zeros shall double. The zeros are 4. Now they become 8. Yes. Now this is the area scale factor for map T. Yeah, for map T. Find the scale for map R. So for map T, we are saying that if we are having 252 square centimeters representing a certain plot, then it means for every square centimeter, there is a 2,500 million, or rather billions, millions, which is a 2.5 billion square centimeters on the land. Then we can check now the actual land. The actual land is going to be, we multiply 252 by 2500, 123, 123. Yes. So when we multiply 252 by 25, we shall get 6300. 6300. And now we have 00, 123, 123. 1, 2. The zeros are, remember 6300 is coming with its own zeros. Then there is the existing 8 zeros. There is the existing 8 zeros. So we add 8 zeros now. after that. Yeah, you have to include these exactly that way. So it means now the actual area is this one. Now the same area on another map is represented by 700, which means if it's represented by 700, then we can get the area scale at that point. And the area scale will mean 700 represented by 60 or 6,300 billion. 6,300 billion square centimeters are representing 700 on another map, or are represented by 700. If it's represented by 700, then we can check what 1 square centimeter represents by dividing this by 700. So when we divide by 700, so we divide this by 700, and we shall get, divide by 700. You know, I'm getting 9, but now 9 zeros should be added. 9, yeah, then I add now like that. 9 billion square centimeters. So it means for 1 square meter, 1 square centimeter, there is 9,000 billion. 9,000 million or 9 billion, which is going to mean if this is the area scale, now we can get the linear scale, since a map can only be represented or can only be described by linear scale. On a map we talk of linear scale. So now we take square root. This is going to be 1:2. For 9 we shall get 3, but now this number of zeros, which are 1, 2, 3, 4, 5, 6, 7, 8, 9. Could there be a zero lagging behind? Because the number of zeros should be even. They should be 8 zeros, sorry. Yeah, 8 zeros. So with the 8 zeros now, we take square root, and this will be 30,000. 30,000. So the idea in this case is, we are taking a area scale at linear scale. We first of all square the linear scale so that we may know area scale factor. Then when area scale factor has been known, now we can get actual area. That becomes actual area. Then now this area on another map is represented by 700. And if it's represented by 700, then we can get the area scale. The area scale for such a map now. Then now if that is the area scale for such a map, then we can obtain square root to know the linear scale for the same map. Number 11, 11 is done. Now number 12. On the diagram below, the line whose equation is 2x minus y plus 6 equals to 0 passes through the points P and Q. Point P is on the x-axis, just as you can see, while point Q is equidistant from x and y axis. Calculate the coordinates of the point P and Q. Calculate the coordinates of the point P and Q. For us to know the coordinates of point P and Q, we should know that for the line y equals to, all right, it's not line y equals to, but we can anyway express it. To remain with y, we'll be having 2x minus 6. 2x minus 6. So 2x plus 6, sorry. 2x plus 6, yeah. Because y is going to the other side, whereby it becomes positive. But 2x and 6 remains on the same side, so they are not changing their side. 2x plus 6 when the equation is rearranged. With this now, we can say that point P is on the x-axis and hence the x-intercept. At the x-intercept, or rather on the x-axis generally, the values of y are usually 0. And if the values of y are usually 0, then we can substitute the values of y to be 0 and say 0 equals to 2x plus 6. So 2x is equivalent to -6, and the value of x becomes -3. Being -3 and y is automatically 0, then the coordinates of P shall be -3, 0. Yeah, the coordinates of P. Again, there is more information whereby we are being told that Q is equidistant from X and Y axis. Let me take you to book 4. Though we are handling paper 1, I can talk something about loci. We usually say that there is the angle bisector locus, and this is the locus of points which are equidistant from two given lines. So when we are told that Q is equidistant from X and Y axis, then automatically Q is lying on a line which bisects the two axes in that way. So along this line, whereby points are equidistant from X and Y axis, the equation is going to be y equals to -x. It cannot be any other line, y equals to -x. If Q was in the fourth quadrant of the Cartesian plane, the same equation would have applied. But if it was in the first, if P was in the first or the third quadrant, then we would have needed a line to be equidistant from X and Y axis. Then that line would have been y equals to x. But for this case, because it is the second quadrant, the line will be y equals to -x. And hence, wherever they will meet now, with y equals to x plus 6 becomes, it automatically becomes the point Q. So we will be having now the equations solved simultaneously. And because they have both expressed y, then we will say if y equals to -x and also y equals to x plus 6, then at the point of intersection, -x will be equivalent to 2x plus 6. And this means that 3x negative equals to 6, and hence the value of x will be -2. The value of x being -2, then value of y can be found very quickly. And if we substitute in this equation, the value of y shall be +2. So at the point of intersection for the two lines, which gives us coordinate Q, it will be -2, +2. That is the coordinate of point Q. Thank you so much for following. Let's continue following. Thank you. If this is a live teaching, yeah, live I'm presenting. That's why I'm able to read your comments. That's why I'm able to read your comments as we continue. Thank you so much. Remember to subscribe. Remember to be a subscribed member. Remember to share this link with your friends. Yeah. Invite someone to this great platform. We can now continue with number 13. The figure below is part of the sketch of a pentagonal prism. That is now talking about the cross-section of the prism, which is a pentagon, means 5-sided. Complete the sketch by showing the hidden edges using broken lines. So we're going now to complete this diagram to come up with the sketch of the pentagonal prism. Pentagonal means we're supposed to have 5-sided. So it's going to be having a face on that side. Or let me use some different ink for people to understand what we are exactly drawing. So we expect pentagonal to be this way. There'll be a phase at that point. So that is one of the phases. Then now we'll be able to draw this way. Draw this way. Then we also bring it this way. We can also show the other phase at this point. We show the other phase at this point because it is a solid. It's also going to have another pentagon at this point. This is a pentagonal cross section. Yeah, pentagonal cross section. It has been shown here. That is the pentagonal cross section. But now there are some hidden edges which we have been advised to use dotted lines. So for the base, allow me to use some dotted line like that. Then we will also have another dotted at that point. Yeah. So now this is my solid now, which is a pentagon, as you can see it. 5-sided cross section. Then now the uniform length. So that is how we get the solid. This number 4. They can see people suggesting a lot of topics, but we will get to them eventually. As we continue discussing several topics, we will find ourselves covering all those topics. Number 14, solve the equation. We have a 4 cosine squared of 2x being equivalent to 3 for the value of x ranging between 0 and 180. So for us to solve such an equation, we need to first of all divide through by 4 and say the cosine squared of 2x is equivalent to 3 out of 4. And this means the cosine of 2x is going to be the square root of this part, 3 over 4. Because cosine squared of 2x is 4 over 3, then the cosine of 2x shall be the square root. And with this now we can get possible values. Possible values of the cosine of 2x. Okay, not cosine, but the 2x now. So 2x can be the cos inverse of root 3 divided by 4. So we need the cos inverse. The cos inverse. So we need shift cosine of the square root of 0.75. Square root of 0.75, and this is giving me exactly 30. So 2x is equivalent to 30. 2x being equivalent to 30, we are supposed to know that there are possible other angles. For instance, when we operate using the unit circle, we can say that all trigonometric ratios are positive, only sines, only tangents, and only cosines. Therefore, at the points where cosines are positive, then we need 30. We need 30 in the first quadrant. And we also need, so we can say 2x is equivalent to 30, comma, that is from the first quadrant. Then where again they are positive is in the fourth quadrant, whereby 30 in the fourth quadrant becomes 330, comma. Again, we proceed and say the square root could have been negative, meaning that we needed a cosine which is negative. And so we need the angle of 30 in the quadrants where cosines are negative. Because of the square root issue, then the square root can be positive or negative. So we also need 30 degrees in the second quadrant where cosines are negative, and 30 in the second becomes 150. When 30 becomes 150, we also check in the fourth quadrant, whereby 30 becomes 180 plus 30 to 110. There can be other options like 30 plus 360. 30 plus 360 when we make another cycle, but now we'll be beyond the given range. So for us to get the values of x now, we have to divide through by 2 and start with 15. Then 330 over 2, giving us 165. Then there is 150 over 2, giving us 75. 210 over 2, giving us 105. So all these are values of x, possible values of x, possible values of x. The four of them, possible values of x. Let's look at number 15, which is on geometry from one work. Using a ruler and a pair of compasses only, construct a trapezium PQRS in which PQ is parallel to SR. Then we also told that PQ is 7.5 centimeters, PS 5.2, SR 4 centimeters. Then the angle QPS is equivalent to 75. Measure QR. We are supposed to know that this question, which is on construction, abstractly we can explain it on this video, but later take time and get the actual drawing, because when we say that a PS is 7.5, then we need a 7.5 at this point. PS 7.5. In other words, I'm advising you on how you will proceed the time you'll be constructing. Thank you so much, those who are commenting. I can really follow up with your comments. Thank you so much. Remember to subscribe. Remember to share. Remember to invite a friend. Remember to be there tomorrow because we shall also be discussing something. Yeah. So that is PQ, PS, sorry, PQ. Then we are told that PQ is parallel to SR. So SR is somewhere up there. P to S is 5.2, and the angle QPS is 75. So at P we shall construct 75, whereby we just start by 90. We raise 90, then we construct 60 degrees at this point. The 30 which remains is also bisected. When you bisect that, you get 15. Once you've gotten 15, now you combine 15 and 60 for you to get 75 degrees. So at P, for you to know where S is some point here, 5.2. You measure 5.2 centimeters and you get S. Then you're also going to prolong this line now and measure 4.2 because of S to R, 4 centimeters. And once you measure, now you drop it to Q. You will have gotten the trapezium. So please work out an actual an actual drawing, make sure you get the length QR. Make sure you get the length QR. There is a number 16 here. Number 16. Today we are not in hurry. Watching from Zambia. Wow, this is great. This is great. Thank you so much, our followers from outside Kenya, Zambia included. I really appreciate such a gesture. All right. The figure below is a sketch of the curve, as you can see it. The area between the curve and the x-axis is on the same side, that is above the x-axis. Use the mid-ordinate with 4 strips. To estimate the area enclosed by the curve, the x-axis, and the lines x equals to negative 1.5 and x equals to 2.5 using 4 strips. Let's see, with intervals of when we use intervals of, from negative 2.5. Yeah, I'm having 4 ordinates. I'm already having 4 units. So I can see we have the first. Can have the first strip. Then after 1 unit, I'll be at 0.5. Then after 1 more unit, I'll be at negative 0.5. I'll be at 0.5. 0.5. After 1 more unit, I'll be at 1.5. And when I add 1 unit, I'll be at 2.5. So these are going to be my 4 strips. Sorry, my 4 strips. So this is the first one, the second one, the third one, and the fourth one. Sorry, I did not manage the space well, but ideally, excuse me, ideally from negative 1.5 to 2.5, we have 4 strips, and the intervals are 1 unit each. That means now, because what we want is the middle heights now, we need to come up with a table of values. We need to come up with a table of values showing us the middle values of y. The middle values of y. So between negative 1.5, and negative 0.5, there is exactly negative 1. In between there is exactly negative 1. So I'm going to get the values of y when x is negative 1, when x is negative 1. Then I also get the value of y when x is between negative 0.5 and 0.5. There is exactly 0. Then between 0.5 and 1.5, there is exactly 1. There is exactly 1. And between 1.5 and 2.5, there is exactly 2. So these are the points which will give me the middle heights for all these strips. So I start with negative 1. So negative 1 raised to power 3. Then I add 7. This is going to give me exactly 6. Then at 0, I will have 7. At 0, I will have 7. Then at 1, I'm going to have 8. At 2, I'm going to have 11 because I'm squaring 2, then adding 7. I'm going to have 11. So these are the values of y, and we know that area using the mid-ordinate rule is estimated using the formula height. Then we add all the values of y, right from the first one, the second one, all the way to the very last value of the heights. Intervals of 1 are the heights. H is the intervals of 1, 1, then 6, 7, 8, 11. 6, 7, 8, 11. So they will be multiplied by 1. 6 plus 7 plus 8 plus 11, giving us exactly 32. And this we will call square units. 32 square units. 32 square units. So that is how number 16 was supposed to go. We proceed to number 17. This is now section 2, and we can check a few things. Thank you so much for remaining around. Nyatigo Mixed, Kisumu County. Thank you so much. How do you determine the interval of the strips? I don't know this method, sir. Good evening. All right. Martin, the math tutor. Mwaniki Martin from Moyale Boys Secondary. Thank you so much, math tutor. Mwaniki from Moyale. I really appreciate. I think we find all the quadrants. Okay, that's a different thing. Thank you so much, Kennedy Odhiambo. This gentleman has seriously been following my programs, and Kennedy, I really want to appreciate you, Odhiambo, for the good work and the consistency that you've been showing. Let me respond to my student from Zambia. He's asking how to determine the intervals of the strips. To determine the interval of the strips, first of all, the number of strips within the provided intervals is what will dictate within negative 1.5 and 2.5. You have said there are 4 complete units, and there being 4 complete units, and we only need 4 strips, then there has to be 1 unit per strip, or 1 unit from one strip to the other. So it's automatically dictated by the demanded strips and the range of values. From negative 1.5 to 2.5, there are 4 complete units, and we need the strips to be exactly 4, which means we're going to use intervals of 1. I think we are together in that. If we had been told 8 strips are required, then we would have used intervals of 0.5 for the strips to become 8. So H would have changed to 0.5. I think I'm making sense. But if anyone feels that there are issues that you really need to consult, even at personal levels, kindly reach out to me through 07 04 15 33 66. So this is the number that you're supposed to use in case you have any issues. Let's proceed with our number 17. With number 17, now we'll be able to say that a sales lady dealing in shoes earns a basic salary of 35,000 shillings. In addition, she's paid commission on the sales of shoes as follows. For sales up to 100,000, 0% commission. But for sales above 100,000, the first 50,000, there is 5%. For the next 50,000, there is 7.5%. And any amount above 200,000, there is 10% commission. 10% commission. On a certain month, she sold 250 pairs of shoes marked at 1,500 Kenya shillings a pair at a discount of 5%. Calculate the total sales for that month. So the sales that this lady made are going to be 250 shoes or pairs of shoes times 1500. But now she did not receive all this amount. She gave out discounts to the clients until she ended up giving 5% discount. And that means we only need 95% of this to know what she got as the total sales. So the total sales, when we compute this 250 by 1500 by 95, then we divide by 100, we're getting a 356 to 150 Kenya shillings. So this is the amount in Kenya shillings she obtained from the sale of the shoes. In number B, calculate her total earnings for that particular month. For that particular month, in the first 100, there is no commission. But in the next 50, because she has gone even to beyond 200,000, for the next 50 or for the first 50,000, there is a commission of 5%. So she's getting what? 5,000 or 50,000 by 5%, giving her 2,500. She continued making sales until there was the next 50,000. And for this, there was 7.5. Let me clear that. There was 7.5%, which means now 50,000 by 7.5 over 100. This gives 3750. 3750. Then finally, there is an amount which is above the first 200,000. The first 200,000. Anything above 200,000, that means we just need to take 3, 5, 6, 250, the total sales, minus 200,000. So there is 156,250. 156,250. 156,250 at the rate of 10%. So by 10%, we're going to get 15,625. So now we can have total commission or total earnings, whereby we will say the commissions are 2,500. We add 3,750. We add 15,625. And we also add the monthly salary because she also earned a basic salary of 35,000. 35,000. Then we're going to get total earnings, which are equivalent to 35,000. We add 15,625. We add 3750. Then we add 2,500. This is going to be 56,000 at the end of the month now. 875. So this is the amount the lady is going to earn at the end of it. Somebody says they cannot understand. I don't know the reason. Please make sure you review book 1 on commercial arithmetic 1. In the next month, our basic salary was increased by 6%. That means basic salary from 3,500 became 106% of that amount. So the new basic salary now is going to be 35,000 by 106 divided by 100. This would be 37 And this is the new salary now. The new salary. Then now, if she earned a total of 47,575 after having sold the shoes at the same marked price and discount, calculate total sales for that month. So if this is what she earned, then it means we can get the commission. The commission will be when we take 47,575 and we subtract the basic salary. Remember, basic salary is the amount she would have earned even without making sales, by just being in the premises of that business. So there is a 10,475. 10,475. This is now the total commission she's going to get. This means there is what we are saying. There is the first 2,500. There is also the next 3,750, and another amount which is now for goods beyond 200,000. So we need to take 10,475 and we subtract 2,500, and also we subtract 3,750. So when we subtract those values, we shall get the commission which came from amounts. We're getting 42.25. This is the commission which is coming from goods beyond 200,000. And so we'll say 42.25 equals to a certain amount at the rate of 10% gave this commission. So for us to get X, now we need to multiply this by 100/10 or simply by 10. And this will be 42,250. So beyond 200,000, she made these sales. So it will be 200,000 and we add 42,250. This is the sales, the total number of sales that she made. Plus 42 or plus 200,000. This is going to be 242,250. Yeah, 242,250. Then the number of these are the sales. Then we want the number of pairs of shoes made. Number of pairs of shoes means that this is 95%. What would have been 100%? 100% would have been 242,250 multiplied by 100 over 95. I'm multiplying by 100 over 95 for me to get 255 1,000. 255 1,000. This is now the amount she would have gotten if she had not allowed discounts. But we had been told that she gave the same discount, which means discounts of 5% are making us get these sales. So these sales are equivalent to 95% worthiness of the shoes. So now we can get number of shoes by dividing this one by 250. 2,500. The price of a shoe, which is 1,500. Sorry, 1,500. The price of a shoe is 1,500. So how many shoes were sold? 170 pairs of shoes. 170 pairs of shoes. So those are the shoes which were sold for that particular month. There's another question here on common solids. I want to believe that you guys are still following. Let me confirm. Oh, Kengwani boys, thank you so much, Kengwani. Thank you, Kengwani boys. We continue following. The figure below shows a traditional artifact made of wood. It consists of inner cylindrical surface, just as you can see, of radius 4 centimeters, and a frustum of the top diameter, which is 12 centimeters, and height 15 centimeters. The pipe that you're going to use is 3.142. The surface of the hood is to be painted, including the inner cylindrical surface. Determine the total area painted to 2 decimal places. Total area painted. The total area painted. So we are supposed to know that for us to get the total surface area, we just have to add all the surfaces that you can see. So there is a bottom circle, and remember radius here is 4 centimeters. The radius is 4 centimeters. Then now that we have 12 centimeters, it means there is a thickness of 4 because the diameter is already 8. The diameter is already 8 for the inner. The diameter is 8, which means when you subtract the outer diameter of 12, then we can get the thickness here. The thickness is going to be 2, 2, because 4 is distributed into 2. That means for us to get top surface, we need pi r squared minus pi r squared, the smaller r. So 3.142 multiplied by a radius of 6, then squared, and then we subtract 3.142. We multiply by a radius of 4, then we square. 4 squared, 4 squared. 4 is the 1 squared, so the bracket should not be at that point, sorry. Yeah, 4 squared, then we enclose our brackets. So we start with 3.142 multiplied by 6 squared. Then we subtract 3.142 multiplied by 4 squared. This is going to give us exactly 62.84. So the top square centimeters. So the top surface, is going to exactly be 62.84. 62.84 square centimeters. Now with the top, we can now add the curved surface. But remember, the curved surface is going to be conical. It's going to be conical, which means now we have to operate with frustum of a cone. Frustum of a cone, whereby we will talk of a known height to be added here, which is h. And then we use similarities and enlargements and say, when we take 15 and we add height h, then we divide by the smaller height, which was cut off from the original cone. We will get radius of the bigger or the original cone, which was 6, divided by radius of the smaller, which is 4. And at this point now, remember we are having 3/2. So with 3/2, we can even simplify now the ratio. 3/2 to have 30 plus 2h. Sorry. 30 plus 2h being equal to 3h. So the value of h is going to be 30 centimeters, which means the bigger height is supposed to be 45 centimeters, the bigger height for the original cone. At this point now, we need to calculate the curved surface, and that means we cannot move on until we cannot move on without the slanting edges. So with the first vertical height of 45 and a radius of 6, we can use 45 squared plus we take 4 also squared, then we take the square root. And this is going to be 45 squared plus not 4 squared but 6 squared. So 6 squared, yeah, for the original 6 squared, then we take square root. Is going to be 45.40 45.40 centimeters. That is slanting height of original cone. Slanting height for the smaller, capital L in other words, slanting height, small letter L, is going to be, we use 4 squared plus 30 squared. We carry out the square root. This will give us a 30.27 centimeters. And this is to mean if we want the curved surface area, which is the outer surface area which is curved, then we will need pi RL minus pi RL, small letters. The curved surface for the original cone minus curved surface for the smaller cone, which was cut off. So 3.142 multiplied by a radius of 6 multiplied by sloping height of 45.40. Then we subtract 3.142 by a radius of 4, the smaller cone, multiplied by 30.27. And through this, we shall get the slanting height for the cylindrical part. Not cylindrical, sorry. Not cylindrical, but the curved surface of the frustum. So I need to start with 3.142. I multiply by 6, then I multiply by 45.4. Then I subtract. I begin again with 3.142 multiplied by 4 multiplied by 30.27. This is going to give us exactly 475.45 square centimeters. So at this point now, I can say we have already calculated the top surface, which is a bigger circle minus smaller circle. Then now the curved has been calculated. We can look at the bottom area. The bottom area is now circular. So the bottom is circular. So 3.142 multiplied by radius squared, a radius of 4 squared. So a radius of 4 squared, yeah? A radius of 4 squared. A radius of 4 squared. 3.142 by 4 squared, giving us 50.272 or 27 simply square centimeters. That is the bottom. That is not all. There is also the inner side. The inner side is cylindrical, and being cylindrical, now you have the inner side. So we're going to take, before we multiply by height, we need to take 2 pi r times h, 2 pi r h. So 2 pi r 4, yeah, multiplied by a height of 15. So this is going to give us 2 multiplied by 3.142 multiplied by 4 multiplied by 15. This is going to be 377.04 square centimeters. So now we are having the bottom, the inner, the curved, and the top. We have all the surfaces, and now we can add up. So total surface. Total surface, now we need to add 62.84. We continue adding. That is now the top. We add the curved, which is 475.45. We continue adding the bottom, 50.27. We continue adding 377.04. We continue adding. Now we take the summation, 62.84 plus 475.45. We add 50.27. We add 377.04. This is going to give me 965.60 square centimeters being surface area. So that is the surface area for all the faces in that solid. It's a technical question. A student must be very careful so that they may get the 6 marks. Then again, calculate the volume of the wood used to make the model to 1 dp this time round. Volume now, we will need volume. For the volume, again, you have to be very careful. We need volume of the first term. Then we subtract volume of the, volume of the cylinder which was drilled out. Yeah. So let's now talk about the volume. And I'll begin by getting volume of the frustum. So for the frustum, I'll need a third pi r squared h. Then we subtract the smaller con, pi r squared h. We can now substitute a third pi 3.142 multiplied by a radius of 6 squared multiplied by a height of 45. The vertical height is 45. Then we shall be subtracting a third pi 3.142, a radius of 4 squared, and a vertical height of 30. So we can compute this. A third pi r squared multiplied by 45. Then we subtract a third, then pi, then a radius of 16, that is 4 squared, multiplied by 30. This is going to give me 1193.96 cubic centimeters. That is for the frustum part. But now with this frustum, we are supposed to subtract from it the cylinder which was drilled out. The cylinder which was drilled out. And for us to know the surface area of the cylinder, not the volume of the cylinder, we need cross-section area by height. So for the cylinder we need cross-section area, which is pi r squared times height. So pi r squared times the height of 15 for the cylinder. So 3.142 times 4 squared times 15. This is automatically giving me 754.08. 754.08. So we can now talk about the volume now for the vessel above. And the volume is going to be 1193.96. Then we subtract 754. Just subtract the two. And we're getting 439 point to 1 decimal place 9 cubic centimeters. So that is the volume now. You're having a field here. Wow, I like these questions. Yeah, let me confirm where we are. Thank you so much for following. I can see people are still in. And this is great. This is really great. Really great. Excuse me. So we have again another Form 1 concept. We can continue a little bit as we wind up sessions. A farm in Laikipia County was surveyed and the measurement recorded in a field book as shown. So this is a surveyor's field book, whereby AB equals to 1200. 1200. Using a scale of 1 centimeter to represent 100 meters, represent the map in the field book. The map is recorded in the field book. We can have it horizontal or vertical, but remember in this case, I'm going to have it as a sketch. I'm going to have it as a sketch. So we need to start. We can have our A at this point. So from A, after moving 250, we have a point P, which is 350. So we can have that one on the upper side. 340, that is. This is P. Then we proceed up to 400, which means from 250, we're just adding 150. So that we move to the opposite side for 400. And now we will be at Q. Then we proceed from 400 all the way to 600 to mean that we are adding 200. So on the side where there is P, we go 150. So 150, this is going to be R. Then from 600, we proceed to 850. To 850 means we are adding only 150. Then we will go to the side where there is R again. The side where there is R, 300. So if this is 300, then we will have arrived at S. And considerably, P is going to be above there. So I take P up here. Yeah, even if it's a sketch, it's supposed to be logical. After S, we proceed to 950, which means we are only adding 100. Then to the side where there is Q, we go to 50. To the side where there is Q, we go to 150. And this is going to give us point T. With point T now, we are going to move from 950 to 1100. from 950 to 1100. That is an addition of 150. An addition of 150. Then to the side where there is S, we move 80. The side where there is S, we just move 80. So this is 80, and we will be at V. And if we are at V, remember we have only moved up to 1100, and the total length of A to B was 1200. So that means there remains 100 here. There remains 100 at that point. So that now we find our B. Some people will make a mistake of not adding the last 100. It's good to be very careful with that point. So now we can connect from the first point. Let me use some different color here. From this point to P, then from P, we should go down to R. We are only connecting the points on the same side, then to S, then to V. Then to V, sorry. Yeah, V is somewhere there. And down to B now. Then on the other side, from Q, go all the way to T, then down to B. These are now this is how the land can be subdivided. This is how the land can be subdivided now. I hope you are following. I just want to hope that you guys are following. Find the area of the farm in hectares. To find the area in hectares, excuse me, that means we need now to calculate all the areas now. Yeah, and first of all, in SI units. So the areas, we can have one. Use this. We can have 1, 2, 3, 4, 5, 6, 7, 8 areas. So area 1 is going to be triangle. So half multiplied by 250, then times 340. That will be the first area. Area 2 is going to be trapezium. So half multiplied by height of 150 and 200, that is 350, multiplied by sum of the vertical lines. Sum of the vertical lines which are parallel anyway in this case. So the parallel lines are 350 and 150. 340 plus 150. Then we continue adding. Allow me to talk about a certain area, which I called area 3. Trapezium again. I have the sum of the 150 and 300, then height between the two, which is exactly 150. That will be area 3. Area 4 is going to be area 4 is going to be again trapezium. So half into summation 380. Then height between them 100 and 150. So 250. That will be area 3. Area 4, that is. Area 5. Area 5 is going to exactly be triangular. So half times 100. Half times 100 multiplied by 80. Half times 100 multiplied by 80. There is area 6. There is area 6, which is again triangular. 150 and 100, 250. Half 250, and the height 250 or so. Excuse me. We'll get area 6. Then there is area 7. Area 7 is going to be trapezium. So half multiplied by the summation of 250 and 400. Then we multiply by the height between the two parallel sides, 100, 150, 200. So 450. 250, 450. Then finally, area 8. As we wind up, area 8, we need half multiplied by area 8 is triangular. So 250 and 150 is 400. And the height is also 400. So we can now get the exact areas. We can obtain now the exact areas for this. The exact areas for this. Let me add them. The exact areas. So we need half multiplied by 400 and 400, giving me 80,000. Then there is a 650. So half by 650 by 450, giving us a 146, 250. There is half times 250 times 250, giving me 31, 250. Then again, there is half multiplied by 80 and 100, giving us a 4,000. Giving us 4,000. We continue. Area 4, 380. So half by 380 multiplied by 250, giving us 47, 500. Then again, we will have half multiplied by 450 multiplied by 150. This is going to be 33, 750. We continue. There is a area 2, which is half multiplied by 350 multiplied by, this is going to be 490. Yeah. So 85, 750. And finally, area 1, 0.5 by 250 by 340, giving us 42, 500. So now we can get the total area now. Total area. So we're going to add all of them. For us to get the total area, we need to add all of them. So we start by area 1, 42, 500, plus area 2, 85, 750, plus 33, 750, plus 47, 500, plus 4,000, plus 31, 250, plus 146, 250, plus 80,000. This is going to be 471,000 meters squared. Meters squared. So that is now the area in meters squared. But now the examiner demands the area to be in hectares. So we have to divide by 10,000. Then the area is going to be 47.1 hectares of land. 47.1 hectares of land. So that is going to be the total area. The same question as another part here. We are told that the figure below shows circular arcs touching each other at A, B, and C. Touching each other at A, B, and C. The radii of the arcs AC and BC, AC and BC are 6 and 4 respectively, or 4 and 6, yeah, respectively. And the arc AB is a quarter of a circle of radius 2 centimeters, just as you can see in the diagram. Calculate the area of the shaded region. Correct 2. Calculate the area of the shaded region. Correct 2. 3 significant figures. Correct to 3 significant figures. So we are just finishing. It's good for you to know that if the radius is 4, then we can have a triangle having the hypotenuse as 10. And the height, we have a 6 here. So with 6, we will have 8 at that point. That means there is a 6 here. To conclude that it is a right-angled triangle. So for us to get the shaded area, we just need area of the triangle first, whereby for triangle, it's already a done deal. Half by 8 by 6, and this will give us 24 square centimeters. That is for the triangle. 24 square centimeters for the triangle. But now we can proceed when we talk about the first sector, the second sector. Yeah, the first sector. Let me call it sector. We can have sector 1, sector 2, sector 3. The first sector, sector 1, we will use a quarter because it is a quarter. A quarter pi r squared, the area there. A quarter pi 142 r squared, r of 2 squared. A quarter pi r squared. So a quarter pi r squared. This is going to be 3.142 square centimeters. That is for sector 1. But now for the other sectors, now that we are sure that this is right angled, we can also get the centers, the angles at the center here, whereby we can say, if this we call theta 2, theta 1 is 90, but now theta 2 can be gotten using any trigonometric ratio. If we say, for example, let me start even in a better order and say the tan of theta 2 is going to be, following theta 2, we need opposite of adjacent, so 6/8, which means now theta 2 is going to be the tan inverse of 6/8. This is eventually giving us what? Shift tan of 6/8. This is giving me 36.87. That is the angle. So, which means sector 2, the sector there now, sector 2 will have theta over 360 pi, a radius of, the radius there is 6 r squared. So divide this by 360 pi 3.142 r squared. This is going to be 11, the area now, 11.58 square centimeters. And finally, we have to find theta 2. So the tan, okay, we don't even need trigonometry now. We can take 180 and we subtract both 90 and 36.87. This gives us theta 3 as 0.13 degrees. So that means sector 3 now is going to be 53.13 over 360 pi, and radius is going to be, remember beta 3 is here, so radius is going to be 4 by 4 r squared, 4 by 4. So this is going to give us, we divide by 360, then we multiply by 3.142, multiply by 4 by 4. This is going to be 7.42 square centimeters. The accuracy which is demanded here is 3 significant figures. Let's first of all add the areas and subtract. So we need now shaded area. The shaded area, we need 24, which is the whole triangle, minus all these sectors, 7.42, 11.58, then the other sector give us a 3.142, 3.142. So now we need to take 24 minus 7.42 plus 11.58 plus 3.142. This is exactly becoming 1.858, but to 3 significant figures, it will be 86 square centimeters. So this is now the area of the shaded region. Thank you so much for turning up. Remember to subscribe. Remember to share with friends. Our number remains 0704 153366. So this is the number that you can use for consultations and any other queries. Thank you so much.